Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 750, number of corner rectangles. Okay, so basically you're given this grid, just a standard matrix of binary 0 or 1s, and what they want you to do is to count how many rectangles there are. And that's literally it. So as long as all four corners are 1s, then just count the rectangle and count how many of them there are and sum up that total number. So let's do exactly that. So notice that we can only do 1s. So let's just call this M and N. So the number of rows and the number of columns. And so let's go ahead and keep track of all the 1s. So what we're actually going to do is, first of all, we can just append I and j if grid ij is equal to 1. Cool. And then the easiest way to do this is just to go generate all combinations of size 4 because a rectangle has exactly 4 corners. And then we can just go ahead and print C, and we want to sort it first. And let's make some observations. So basically, notice for this one, and I also think this is a good test case because let's just use this one for now. So the only one, if we go ahead and paste this here, and let's just try to visualize it. So if we move that here, notice that this is a square but also a rectangle. So 1, 2 with 1, 0, 1, 2, 3, 4, and then also 2, 2 with 2, 4. So am I doing that right? 0, 1. So 1, 2, yep. And then 1, 4. And then 0, 1, 2, 3. So 3, 2, and 3, 4. So if you notice what's going on, it becomes pretty obvious that you're just trying to have, first of all, the rows, because to make a rectangle, you have to go down. You can't go up. And so first of all, these two have to be bigger than these two, right? So let's just go ahead and say if C of 0, and they have to be equal to each other because a rectangle cannot be like this, right? So if C0 of 0 is equal to C1 of 0, and C of, so basically 3 is equal to 3, so if C of 2 of 0, or, yeah, so C of 2 of 0 is equal to C of 3 of 0, and we also have to make sure that C of 0, because they're already equal, is less than C of 3 of 0, right? We have to check that this is bigger than this, and same here, and they're equal. And then, as long as these columns are also equal, so if C of 1 of 0, or C of 0, 1 is equal to C of 2 of 1, so 2 and 2 here, and C of 2 of 0 is equal to, so 0, 1, 2, 3. So C of 3 of 0, or C of 3 of 1. So we're comparing the ones, right? 0 is equal to 1, and then 2 is equal to 3. Okay, in that case, we can just increment it because that would be a valid rectangle we formed. And let's see what's going on, because C0, 1 is equal to C2 of 1, and 1 of 1 is equal to 3 of 1, right? So we're actually skipping there. Okay, cool. So in this case, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. So then we can just go ahead and return answer at the end, right? So let's run this, submit it. And so this is exponential time complexity. So let me show you how I optimized it. So the way I thought of it was, if we're just trying to do whatever we did here, why don't we just go ahead and keep track of the x's, right? And then for each x, for the y's. So let's just say xx of the x coordinate, and then the value is just going to be all the y values. And then let's just go ahead and actually sort the keys. So let's call this kk as sorted xx.keys. So we're just going to sort of do a double loop to find each pair of x's. So let's get rid of this. Okay, so what we're looking for is, as we do a double loop, as long as this one's bigger than this one, then we're interested. So for I in range length of kk, for j in range I plus 1 length of kk, because I can't be the same, right? So this is just going to be this, and then whatever the other one is intending to be this and this. So then we can just say 1, 2 is kk of I, and kk of j. So if 1 is less than 2, then we're actually interested in the dictionary, right? So then we can just say OO is just going to be xx of 1. So yeah, okay, because these are the values, I think. TT is xx of 2. So let's print OO and TT, and let's also print 1, OO, 2, and TT. So now we're looking to find, because you can see that 0, so if we get rid of this, so we have a 1 at position 0, 0, and then we also have one at 0, 3, and then 1, 2, and then 1, 4. So we're doing like a pairwise operation over these to compare them. So first of all, if length of 1, 1 is bigger than 1 and length of TT is bigger than 1, then we can do that, because otherwise they're not even pairs, right? If we're just doing a pairwise in here to compare, right? Cool. So now we know this is bigger than this, the x's, and then we're trying to find a y that is also equal. So why don't we just go over, let's just call these x vals, y vals is OO, and then TT, and let's just say so we're trying to find pairs that are also in here, and that's just going to be one more corner rectangle, right? So then for A in range length x vals, for B in range I A plus 1 length of x vals. So the pair is just going to be, let's just call this AABB is x vals of A, x vals of B. So if AA is also in TT and AA is also, BB is also in TT, then we can just go ahead and say that's one more answer, right? Because that would be matching. Let's say here, this is matching because 2, 4 is in X, or is in both of the lists, right? Okay, let's run this. Okay, submit it. Okay, time limit exceeded. This is probably not the most efficient. We can probably make use of a set. And let's try that. Okay. So this is still a O of n cubed solution, right? Okay, still time limit exceeded. Okay, so what we probably want to do is just say, if it's in y vals, right? Y vals is what we created the hash set out of. Okay, submit it. So it's O of 1 lookup instead of O of n lookup, which makes a big difference. Okay, 92 out of 94. So let's try to squeeze a little more out of this. So what I ended up doing was just saying if x vals of A is not in y vals, then we don't even have to run this loop, so we can just continue it. And let's try it again. Okay, xvals. Okay, submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.